Okay, hi and welcome to video notes 8.1 and really 8.2. This is on the properties of exponents. So right now you should have seen exponents somewhere before. It shouldn't be brand new to you. In doing exponents, I'm going to refresh everything that you kind of know what it is and then basic properties today, and we'll do basic properties the next 2 days. So we'll get a lot of properties about exponents and you should be pretty good at them by the time that we're done. Okay, so the first thing I want you to know about the properties of exponents is that really these are like a mathematician's shorthand. What is shorthand? That's when you take a word and you write it shorter. By the way, is commonly written as BTW, at least in my age it was. So let's take a look at what shorthand that you're familiar with, that you've been working with a lot, that you might even understand a little better. So consider taking 2 and adding it to itself 4 times. 1, 2, 3, 4. So 2 plus 2 plus 2 plus 2. And we could do that. It's nothing wrong with that, but it's a really long way to write it. We like a way that's a little bit shorter. So what would be another way that we could do this or represent 2 plus itself 4 times so that it's a little bit shorter, right? And that would be 2 times 4. Right? So that's how we represent this long piece, right? It's 2 times itself 4 added to itself 4 times, right? Which is 8. And we're comfortable with that. We're very familiar with that. That's where multiplication comes from. It's a way to shorten or abbreviate additions or long additions or multiple additions. So that's really what I want you to think of that an exponent is. It's kind of the same thing. It's a way to take a number, so look at this, 2 times 2 times 2, and notice the difference between the two. This is multiplication this time, right? So how do we represent something that's multiplied by itself a whole bunch of times versus added to itself a whole bunch of times? Well, addition is multiplication. Guess what exponents are? Exponents represent multiplication of that number to itself however many times. So this, you're probably pretty comfortable with this. If we were to condense this multiplication of 2 3 times, we'd write 2 and we'd raise it to the power of 3 because there's 3 of them. 2 times 2 times 2, or 3 times. The number, the main number, the big number, right? You can even write big here if you like, is called the base. Really, every number you know could be represented as a base. So if I wrote the number 4, we could call it a base. It's another name we could attach on there. But if we call it a base, we're really indicating there's some type of exponent. And if 4 has an exponent that we don't see, it's 1, because that would say it's 4 times itself once, or 4. Okay, so we wouldn't really call every number a base. But if we're talking about an exponent, then we want to use that term base. Exponent then is the small number that's raised up. And this can be tricky. You really want to make sure that when you do an exponent that it's really kind of up in the top, because if you're doing something you might write 2 to the 3. Well, I don't know if that's 23 or 2 raised to the 3 in this case. So make sure that you go in and take your time and really make it look like an exponent. So that's what an exponent is. It indicates the number of times that the base is being multiplied to itself. Now that we know that, let's go ahead and do some more condensing of multiplication so we can see them as exponents. So in this case, we've got a variable. Yeah, it works with everything. It doesn't matter if it's a number, a variable, constant, whatever. So in this one, I've got x times x times x times x, which means it's x times itself 4 times. In this case, we want to look at this one probably a little bit more carefully. We've got the quantity of -3, right? It's not just 3, and it's not negative on the outside. This would be separate from a negative times 3 times 3 times 3. These would be different. The results in this particular case would be the same, but they are different. What's happening here is, well, let's do it first, I guess. Mr. Hallam, slow down. Let's do what it looks like. It's going to be -3 raised to the 3rd power, because there's 3 of them. If you look at this, what's your result of actually multiplying this out? Well, 3 times 3 is 9. 9 times 3 is 27. Is it negative or is it positive, you have to ask yourself? Well, what does a -3 really mean? It's -1 times 3, -1 times 3, -1 times 3, all multiplied by each other. So really, this piece here, if you look at it really carefully, it's -1 cubed, right? Because there's -1 times -1 times -1, and it's multiplied, 3 there is multiplied by itself 3 times. Well, what is -1 times -1 times -1? It's a negative, isn't it? Yeah, it is. So if that's a negative and then 3 cubed is 27, the result is actually negative. here's the tricky part. Are you ready for this? If I add another negative 3, so let's do it right down here. So if I add another, well, let's take one away to shorten it up. But sometimes if I have two negative 3's multiplied to each other, well, let's look at that. It's going to be negative 3 squared, right? Yeah, of course. Well, that means negative 1 squared times 3 squared, right? Well, what's negative 1 squared? It's negative 1 times negative 1. Two negatives make a positive in this case. So even though the number, our base, is negative in these, we have to kind of pay attention to the exponent. If it's even, the negatives will cancel each other out. If it's odd, like these here, so if it's odd, then it will end up as a negative because there's a leftover negative 1 in there. If it's even, it's going to be positive. Well, let's finish this problem. I didn't write out what it would be. It'd be positive 9. So what we just learned then is even powers of a negative number, right? It has to be in the parentheses, not this one here where I said it's on the outside. Outside is different. That'll just result always in a negative number. So this one will always be negative if it's on the outside. Okay, if it's on the inside though, we have to pay attention to the power. So even ones will be positive as a result, and odd powers, where there's a leftover negative 1 that didn't cancel out, right, will be negative. So that's a rule, again, in parentheses. Make sure that you have the parentheses there. All right, so that's a nice little rule there. Let's do one that has a mix of a constant and a mix of a variable. So this is 5 times 5 times 5, or 5 cubed. And then it's multiplied. Make sure that, notice that all of these have multiplication implied, right? Or showed in this case. And then we've got x times x times x times x, or x to the 4th. So right now you're thinking, hey, I'm doing pretty good with this. I'm all set. All right, great. Let's expand them then. Okay, so if I take 4 cubed, that's as simple as 4 times 4 times 4 times 4. What about negative 3 to the 5th? Negative 3 times negative 3. You don't have to write the multiplication, by the way, for the parentheses, because it's implied. So times negative 3 times negative 3 times negative 3. I think you're getting the point. Let's do one more. 3 squared is 3 times 3, and then I should have 5 x's. Times x, times x, times x, times x, times x. Now, are we ever going to expand them? Probably not. Very rarely will there be scenarios where we need to expand them. There may be times, but really we're going to do more condensing than anything with this. All right, so let's move on to two new properties with exponents. So the first property is pretty much what it says. There's not a lot to say about it. It's that at any base, any at all, variable, number, whatever, raised to the 0 power, it could be a smiley face. Its result is 1. That's just the property. That's the way that it works. Don't question it. Just memorize it. Actually, let's write memorize down. You may already have memorized it. So that's just one to memorize. Every time you see anything to the 0 power, it's 1. I don't care how big and complex it looks. All right, so another property that we should spend a little time talking about is the negative exponent property. Now, a negative exponent, which we didn't explore up here in our examples, no, so we didn't talk about them here. So if you have a negative exponent, really what it means is it's a movement or a direction. That's how I look at it. Okay, so what it's telling you is to take that base, if you see a negative exponent, and move it. Well, where are you moving it to? Well, every base, if it's a whole number, an integer, right, is over 1. It's in the numerator. And then if it's in the denominator, that's the location. So really what we're talking about here is movement between the numerator and denominator. So you're going to move it from wherever it's at. If it's in the numerator, you're going to move it to the denominator. If it's in the denominator, you're going to move it to the numerator. Once you move it, you're going to change its sign. So a negative exponent is really telling you to move position and then change the sign. That's what it's telling you to do. That's what this is explaining. So it says here's the base of a, it's raised to the negative n. It says move its position, so you'll see me do this circle and arrow quite a bit with these, right? So take it out of the numerator and put it in the denominator. Well, what stays in the numerator? Well, just like the denominator, if we want to put it in there, it's a 1, right? It's a placeholder. So if there's nothing there, it's a 1. If there's something there, it's under multiplication or addition or whatever it is, right? So it also works if you're in the denominator and you have a negative exponent. It says move its position and then change its sign. That's how that property works. Okay, so you have to be able to go both ways. It's useful because we're going to get down here and talk about what we have to have, which is positive exponents all the time. So you're not allowed to have negative exponents. So this is an important rule to know. Okay, so let's do some examples now. So example, 5 raised to the 0 power. Well, we just learned that every one of those is going to turn into 1, right? Here's a complex one, or a little bit more complicated, right? It's a negative 0.02, negative 1.02. That's just going to turn into 1. Doesn't matter what it is, okay? All right, here's an example here, 3 to the negative 4th. So we're going to check this negative exponent property. So what I'm going to do is remind myself that that's in the numerator because it doesn't look like it's in the denominator, and I'm going to circle that. You take its exponent. I don't know if I said that. You move the exponent as well. You move the whole piece, so I'm going to move it down, right, and then I'm going to change its sign. So there's no number multiplied to the 3, so I'm going to use 1 as a placeholder. You will see some where there's a number multiplied there. You'll see it in the next page. So I'm going to move it down, and then I'm going to change the exponent sign to 4. That's it. Now we could work that out. That will be, right now, if for our algebra purposes, we're going to usually leave things like this. Multiplying out that number, I mean, it's 81, so actually let's just change this number sign to 81, so it'll be 1 over 81 is the end result of that. That's only when you're at your final. You don't really want to expand or I guess don't calculate until the very end. Till you're at the very last step of whatever you're solving or simplifying. Because sometimes having it in the exponent form can lead you to quicker, easier ways or combine with things that you might not see. So don't go ahead and break that open to 81 until it's like your last step or you can't go any farther. Okay? All right, so here's one. We've got a negative 8 raised to the 3, right? So in this case, we just need to know what that works out to be. So, and I don't know if I remember what negative 8 times negative 8 is 64. I don't know if I can do them in my head, so let's do this. This is what a calculator looks like if you don't have a graphing one. So I'm going to do 8. I'm going to pretend that I'm not going to pay attention to the negative because I'm going to address that on my own. I'm going to use my properties here. So I'm just going to type in 8. This would be the symbol for the exponent. You'll notice a lot of times that it has a caret key on there, right? And then I'm going to type in whatever it was to. I think it was to the 3rd. And that's going to tell me it's 512. So I'm going to go back to this one. Now the reason I'm not paying attention to the negative is because I have this fancy property up here. I'm going to look at the power at the exponent. If it's even, my result will be positive. If it's odd, it will be negative. So this exponent happens to be a odd exponent, right? So my result then is negative for this situation. So I'm going to take that. We said it was 512, correct? I think I already forgot. Yep, 512. So this is going to be 512. And its result will be negative. That's how I'd like you to address that. You can type them into the calculator, but it's difficult at times depending on your calculator. In this one, if you were to do it, you would put parentheses, you'd put a negative 8, at least I hope that's how that works. You'd close the parentheses, then you'd raise it to, see now it tried to subtract. So there's got to be a negative sign, or it doesn't like negatives. Yeah, there's a negative sign right there. So we would do parentheses, negative 8, is it like that? Negative 8, there it is. And I'm going to close my parentheses, and then you can do it to the 3rd power. It will tell you it's negative 512. But I'd like you to have enough number sense to be able to do that by the rule, and that way you don't have to worry about the negative. And then if you put it in the wrong spot, or if you forget to put parentheses, if you typed it in without parentheses, it may change your answer, especially if it's an even power. All right, here's another one for the negative exponent. We're going to realize that that's in the numerator, so we're going to take that base and its exponent, move its position to the denominator, use a 1 as a placeholder, and it's going to become positive 7. This one is kind of what I'm talking about with this one. This is not the same thing. This is a negative 8 cubed. This is 2 cubed, then multiplied by a negative 1. So what this really looks like is this. So we would take 2 to the 4th, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. So we're going to find out that it's 16, but there's that negative 1 hanging out. So even though it's an even power, right, don't confuse it because the whole base is not negative in this example number 6. It's going to result in negative 16. So you have to watch for that, okay? So again, I referenced this a second ago. It says all algebraic expressions are in the simplest form when written only in positive exponents, okay? That's really what we want to pay attention to. So we're looking these examples here, and we're going to notice that somewhere in here we're going to find a base that's raised to a negative exponent. Well, what do? Well, we're going to take that according to our negative exponent property, and we're going to move its position. This whole thing is in the numerator, correct? You can see that. These two are going to stay in the numerator because there's no negative exponents to move them. But the y is going to move. So what the result is, 4x stays in the numerator, y moves to the denominator, its cubed comes down with it, and we change its sign. Pretty simple. All right, so this one is in the denominator this time. 1 is our placeholder. We're going to move it to the numerator, so it's going to go into the top, and we're going to change the sign of the 4, or the exponent. And we can put it over 1 if you want, but really that's redundant in math. We don't like to write that. So looking at number 11 here, again, the only thing that the exponent to is the b. That would be far different if I had a set of parentheses here. Then that's what we're going to talk about in the next 2 days. If there's parentheses, all 3 of these values, 3, a, and b, would be raised to the negative 2. So that would make us do something different. But in this case, it's only the b. So we're going to move the b. Again, it's over 1 as a placeholder. So 3 and a stays in the numerator, b goes to the denominator and becomes positive. And this one you can pretty much guess is going to move up and become x to the positive third power. Okay. So, last little bit before we're done, it says when you evaluate an exponential expression, write the expression with the positive exponents before substituting values, which means that you don't do this. You don't say, oh, look, here's an n and a w, here's what n's equal to, here's what w is equal to. This is directly in your book, in your homework. Do not do this. Do not plug it in and put negative 2 raised to the negative third power. Do not do. Do not do. Okay? Do not do that. And then plug in the w, so it would be 5 raised to the 0 power. Will it work? Yeah, but what you're doing is complicating. You're complicating by putting those in. You're adding too many things. The variable actually makes it easier. So do not do that. The way that we would do this one, right, is that we would simplify this first, right? Move any exponent rules that we need to. Sorry, I'm trying to erase those marks. So what we would address is first this, right? So we're going to say this is in the numerator, so we're going to move that to the denominator and change the sign. And then additionally, we've got a second thing that we can do. We'll just do 2 and 1. We know any power raised to the 0 power is just 1. So the w that's going to stay in the numerator is going to turn into 1. And the n is going to go to the denominator and then become a positive cube because we have to change the sign. Now you put that in. Okay, that's when you do this. So if I put equals 1 over negative 2 to the third, right? It's a negative base, correct? That's why we use parentheses when we substitute, so that we make sure. Otherwise, you might put a negative 2 and you do it wrong. All right, so this whole negative base, right, is going to result, because it's odd, is going to result in a negative answer. So 2 times 2 is 4, times 2 is 8. So we're going to get 1 over negative 8. And again, you don't have to leave it the denominator. It's the same thing to put it in front, and it's the same thing if you put it in the numerator. It doesn't matter. Negatives can be in any position. It all means the same thing. All right, let's tackle another one. Here's 14. So this one's telling me to take this n, that base of n, and move it to the denominator. There's a w squared down there, and there's not going to be anything in the numerator. So since there's not going to be anything in the numerator, we're going to put a 1 as a placeholder, and then we're going to go down here with the w. I'm going to put the n in front because n comes before w in the alphabet, so I'm going to put it in the front. It's got a power of 1 now, positive 1, because we moved it, right? Switched its sign. So I'm not going to write 1, and then I'm going to write w squared. The implied operation when you move a negative exponent, or any base that's raised to exponent, the implied operation is multiplication. So I'm going to put them next to each other. I don't have to put the sign. It will never be addition or subtraction. Always multiplication. All right, moving on to 15. This whole piece is going to turn into 1, and this n is positive. So really what we end up with is n over, or 1 over n to the 4th. Sorry, I didn't plug in. I'm going to skip the plugging in part. Now you would plug in your n, and I'm sorry, your negative 2 and your 5, and then you would plug it in here as well. I'm going to skip that part. I'll let you guys handle that. That's a calculation you can make on your own. I just want to talk about the exponent properties. All right, the last one then, this one's in the denominator with a negative, which means move it to the numerator. That means it's going to go into the top of the fraction, so there's w. It becomes a positive 2 over n. Then you would evaluate. Now you'd plug in your values. Okay. All right, so there's all your properties. Main ones to pay attention to are your negative exponent properties, right? That's a big one. Property of 0, and then of course these two right here, where your result of a negative base, right, if it's an even, becomes positive, and odd becomes negative. All right, so thanks for watching. We'll see you in class.